How you doing? My name is Demetrius Sanford.
And I'm Brandon Wood, and this is the range of a football formula.
Brandon and Demetrius are throwing a football. They are standing at a distance of 10 meters apart. Assuming the ball is thrown and caught at the same height, what is the maximum height the ball reaches, and what is the velocity right before the ball is caught? Assume the angle which the ball is thrown is 45 degrees in order to reach the maximum height possible, and the time it takes the ball to travel the 10 meters is 1.58 seconds.
So now we're trying to find the max height with the variables already given. We're trying to find y. So from the equation, we see that we have a 10 meter total.
So the x would equal 5 meters.
So half of that distance would be the max height, the time it takes to get to the max height. So if you want to come over and do the triangle. Our theta is 45 degrees there. We're looking for the y. And 5 meters because of the half distance. So we have to set up an equation for y using our tangent.
Tangent 45.
It'd be tangent 45 is equal to that. Y over 5 meters. And then now we solve for the y.
It's right here.
Oh yeah, I have a calculation too.
He has it all calculated.
So it's equal to y.
It's 5.
So y is equal to 5 meters. And that would be our max height. So now we're trying to find the final velocity. And this is the equation for final velocity. So now we get rid of the things that we do not need. So velocity initial is 0. And then our theta x, or not theta x, our delta x is 10 meters. Writing in our equation, so acceleration is 9.8 due to gravity. 2 times 9.8, 1 times 10. 196.2 meters per second, or meters squared per second squared. Now you take the square root. V is equal to 14.007 meters per second. And that's your final velocity. Next, we're finding the max height at 20 meters. The distance of 20 meters in the x direction. So we're going to use the same triangle with the theta of 45. The total distance cut in half because max height is half. It'd still be tangent of 45 set equal to we're solving for y. Using the calculator, we'll figure out that y is actually equal to 10 meters, and that's your maximum height.
Starting off with the kinematic equation.
Yep. Next, we're starting with final velocity at 20 meters. We start with the kinematic equation for final velocity.
Now Brandon and Demetrius are throwing the ball from a distance of 20 meters. Assuming the ball is thrown and caught at the same height, what is the maximum height the ball reaches and the final velocity right before the ball is caught? The angle stays the same, but the average time is now 2.23 seconds.
acceleration due to gravity is 9.8 meters. So it's 2 times 9.8 meters per second squared times 20 meters equal to 392.4. And because velocity is squared, you have to take the square root of the whole equation. Taking the square root of the whole equation, velocity final is equal to 19.809 meters per second. And that's your velocity final.
In conclusion, in this video we use the kinematic equations to find the maximum height and the final velocity of a football thrown at a distance of 10 meters and 20 meters.